So let's look at the example where you will have a huge nested loops. We have go through some nested loop example. We have go through a nested loop for two-dimensional array, and we have to go through nested loop to go through the relationship between elements in the one-dimensional array. And in both cases, we used a two-level nested loop. But now we want to calculate the product of two matrices. The product of two matrices is a calculation between two matrices when the inner dimensions are the same, meaning the number of columns of the first matrix is equal to the number of rows of the second matrix. The product can be defined as this. So let me bring up some example. Like if the first matrix is 1, 2, 3, how about 1, 2, 3, 4, and 5, and 6. This is for matrix A. Then we shall have a product which is 1, 2, 3, and 4, 5, 6. So the first matrix is a 3 by 2 matrix. A is a 3 by 2 matrix. And the second matrix is a 2 by 3 matrix. Then the inner dimension, the column of A of the first matrix and the row of the second matrix, they are the same. So we can perform a product between these two matrices. And the new matrix IJ will be the new matrix will become 3 by 3, and its IJ will be calculated. Each element is going to be calculated this way. If you have learned linear algebra, it's going to be very easy for you. If you haven't learned linear algebra, that's okay. You just need to know that we are calculating a two-dimensional matrix based on two-dimensional matrix. And as you can see, each matrix is actually a two-dimensional array. So to calculate a C, matrix C, which is 3 by 3, you will have to have two levels of nested loop for C, right? You need to have the I and J to go through every element of C. Now, inside every element of, to calculate each element of C, you will go through A and B. So here you can apparently see A will, for A's column, we will have 1, 2, all the way to N. And for B's row, 1, 2, all the way till N. So there will be 3 levels of nested loop. Okay, and because this is we have a clear mathematical definition, so I'm going to directly write this. Assignment 10 matrix product. Actually it's a MA lowercase. And I'm going to save it, and I will need to change the name to make the a rename file. Okay, so we will have a public static void main string array args, and we also need to add Java doc, which will give us this. So it will be a simple one. We will define matrix A and the B. So we will have an int A equals to it's a 2-row. So it will be 1, 2, 3, or am I? Oh no, it's 1, 2, and 3, 4, and 5, 6. So this is A. Now let's create B. And B equals to 1, 2, 3, and 4, 5, 6. Okay, now calculate C. How do you do that? Because when you calculate C, as the definition suggests, you need to go through each and every element of C, right? So it will be for each row of C, for each column of C. And of course, we need to make a definition. Int C equals to new int, and it will be A's length, row length. How many rows does A have? And B's, the first row of B's length, which is B's column length. So now let's do this for int I equals to 10, 0, I less than C dot length, I plus plus. Then for each column of C, for int j equals 0, j less than C I dot length, j plus plus. And then C I j equals to, here you will need one more level of the excuse me, you need one more level of loop. So it's 1 to 2 to n. N is the size, is the row number of B. So we will have to put something here. Cij is the sum of a ik, sum of ik times b k j, right? You can see that it's aik times bij pkj, aik times bkj. So, and here we will have 4 int k equal to 0, k less than b dot length. That's the number of rows in B, and the k plus plus. Initially, this apparently is a running sum issue. So we will initialize that to 0. We actually don't need to, but it's always a good habit. Plus all right, so now that we have it, I dropped the T here, we will print out Cij. So instead of setting this to 0, we're going to have a system dot out the print. Note that this is print out each element, so we will need to print out a line after the row is completed. So let's run it. Oh, I need to add the space. And you can see, let me move this a little bit down. And here, if I move this up, the first element, A11 or A00, depending on how you calculate, it will be 1 times 1 plus 2 times 4, which is 9. And the second one is this one. Oops. Three times, okay, it's not. The second value of is, this is this a 1 and 2, right? So it's a 1 1 times 1 2 here 2. So 1 times 2 plus 2 times 5, that's 12. And the last one is 1 times 3 times plus 2 times 6, which is 12. So 3 plus 12 equals 15. So that's how you calculate the product. So the purpose of this one is more give you a idea on how nested loop can be created. You can have more nested loop inside, but usually nested loop will not go beyond 3. Nested loop of 3 levels. Nested loop beyond 4 levels is extremely rare and is very costly. Usually, you should be able to find some way to calculate that, because in real world, you should not encounter such a huge, dense calculation unless you work for some really large companies. At that time, the most important thing for you to work on is how to optimize the performance. You don't want to have like 5, 6 levels of the nested loop running. Rather, you will have some more advanced technology like distributed computing to handle this kind of calculation instead of running a 5-level loop in the machine.